All right, so from this, what can I plug in? I'm going to have the chat open on this other one if you guys have any questions. So I'm going to have this for the X direction. And this for the Y direction. It looks like I need to move the computer a little bit the other way. I have 3 computers going right now. Yeah, I might be too close. Sorry about this. I'm trying to. All right, could anybody put anything in the chat that we know about this gun that is shot from a height of 1.7 meters? Any velocities? Any displacements? Any accelerations? Anything we always know? So in our Y direction, our acceleration is going to be -10. And on the lab today, I think I have you guys use -9.81 because that's what the simulation does. Anything else? V naught is 200, X direction, V naught and V is 2. Okay, good. So we know that when we shoot something sideways, all of the velocity is in the X direction. And our Y direction, initial velocity is 0. Because these are the same, we also know that our acceleration is 0. And we know how far the bullet's going to fall down. And so that's 1.7 meters. Because it's going to land 1.7 meters below where it started, that's going to give me a displacement of -1.7. So for problems like this, and these will be like the ones you'll do in the lab today, the first thing you should do is solve for time using the Y direction. So it's going to turn out that the time of flight is only dependent on what's going on in the Y direction. It's completely independent of the X direction. So I'm going to look at my equation. X minus X naught equals V naught T plus 1/2 AT squared. Hopefully you guys can see that. It's behind the chat on this other computer. And then what's nice for these, and that's what's going to make it more complicated when we do the ones at an angle, is that's not always the case. Is that things will always cancel out for us. So in this case, if I'm dealing with the Y direction, I know that our initial velocity is 0, and so this whole term goes away. The V naught T doesn't matter. And so it's X minus X naught equals 1/2 AT squared. So I'm going to multiply by 2. I'm going to divide by A, and I'm going to square root. And that's going to give me the T. Now, again, you can do this step by step, or you can do it all at once. But they do want to see the original equation and then the final equation. And then what I'm going to do is I'm going to plug in what I know. And so I have 2 times negative 1.7 divided by negative 10 squared. And on those Edpuzzles, I solved a number of these with you guys. All right, so if you forgot to make the displacement negative or the acceleration negative, your calculator will let you know right away because you'll be taking the square root of a negative and it'll say you have an error. All right, so 2 times 1.7 divided by 10 square rooted. I got 0.58. And so once you know this, you can plug it in to that chart. I can plug it in for the time over here. Because it's the same time. Because it's representing the time from when the bullet leaves to when it hits the ground. And speak up if you guys have any questions or anything. I do have a chat open, but... All right, so now that I have that, I'm going to look at the x direction. And the same equation, dx minus x naught equals v naught t plus 1/2 at squared. And now there's no acceleration in the x direction. We don't know why that is yet, but there's no acceleration in the x direction. So this is going to cancel out. And so then I can just plug in the givens. X minus x naught is equal to 200 times 0.58. And so it will land 116 meters away. It looks like I need to lower this down a little bit so you guys can see that. So we have 200 times 0.58. We canceled out the A, and we have 116. I'll give you guys a second to get that loaded up. And I'm taping this, so once we're done with the 2 examples, I can load them up to my YouTube channel, and I can share a link to our Google Classroom. So you'll be able to go back and look at them again. It's the same thing with the Edpuzzles. Those are all videos from my YouTube channel. So if you ever wanted to look at a problem being done or slow things down, that'll be an easy way. Because I do ask you guys to do a number of horizontal launch things today. Does anybody need a little more time on this screen? If you could put it in the chat. We're all good? All right, I'm going to go to the second one. And I'm going to scroll, put my screen up a little bit so you can see it. All right, so half of the problems that you're going to see are going to be in terms of variables and not in terms of numbers. So I wanted to show you guys one of these as well. So a diver jumps from a cliff of height h after jumping completely horizontally with the velocity of v naught. Calculate the time of flight and the distance d she lands from the edge. So again, I'm going to start with two charts. Now in a problem like this, even though you know that the acceleration is -10, you're going to want to just leave it as little g. So that's our constant. We don't want to add any extra numbers into our equations that we don't have to. Anything else we know? Anything else we know? We should know the same thing as we knew in the last one. We just have letters for them now. So we know our acceleration in the y direction is g. We know that in the x direction it is 0. We know our initial velocity in the x direction is v naught, and our final velocity in the x direction is v naught. And we know that our initial velocity in the y direction is 0. So I want to get the time, and I want to get the horizontal distance. So using the y direction, I have x minus x naught equals v naught t plus 1/2 at squared. And I can cancel out v naught t because v naught is 0. Oh, the last thing I know is that x minus x naught is h, right? That'll be helpful. All right, so I want to get t by itself. I'm going to substitute in their letters. They'll be specific about what letters they want you to solve for, and you'll see as you get into more of the examples what this is. So my x minus x naught is h, and my a is g. And so I'm going to multiply by 2, divide by g, and square root. So this is going to be my time of flight. Radical 2h over g. So that's going to go into my chart here. And there. I'll give you guys a minute to get caught up. So in general, the time is going to be the square root of 2 times the displacement divided by the acceleration. And I'm assuming that this diver's on Earth because they didn't tell me otherwise. All right, then I can consider the x direction to get the range. Same equation. And now the acceleration 0, so that part cancels out. So now for the horizontal range, which isn't h, that's what we're solving for, we're going to put in their letters. So they tell me that my initial velocity is v0 and that my time is 2h over g. So these would be our answers in general terms.